Noting the difference between a scalar and vector will determine how you proceed with future calculations. A scalar is a quantity that only has magnitude. Magnitude means how big something is, a number, or an amount. Example of scalar are distance and speed. Vectors have magnitude, so how big something is, the amount, a number, but it also has direction. Examples of vectors are displacement, velocity, and acceleration. Let's say we're traveling from point A to point B. So if I want a scalar quantity, it is 4 meters to travel from A to B. My 4 meters is my magnitude. If I want a vector quantity, my magnitude is still 4 meters, but now I have a direction to the right. So a vector must always include direction. Let's say I'm making a round trip. If I'm making a round trip, starting at A, going back to A, my scalar quantity is just the addition of all the numbers. So it's going to be 4 meters, or the perimeter, plus 3 meters, plus 4 meters, plus 3 meters, which equals 14 meters. However, my vector quantity is going to equal to 0 because I started at A and ended at A. So I didn't go anywhere. Let's say I'm going from A to C. And again, for scalar, we just add the numbers up. So for scalar, it's going to be 4 meters because it has to go from A to B. Then it has to go from B to C, which is 3 meters. So this is 7 meters total. For a vector quantity, since direction is accounted for, we must take the shortest path. The shortest path to get from A to B to C is from A to C. So my shortest path from A to C, if you notice, is the diagonal of this rectangle. Since this rectangle is a right triangle, the shortest path, we must use the Pythagorean theorem. So R, if we label the resultant R is going to equal to A squared plus B squared, take the square root. If we say 4 is A and 3 is B, this becomes 4 meters squared plus 3 meters squared, take the square root, which equals 5 meters. Since vector also has direction, we must give a direction. Example of this could be southeast or from A to C. So a scalar quantity, we do not need to account for direction. So we follow the generic math rules. For vector quantities, we need to account for directions. After we account for direction, we follow the math rules. So how do we account for direction? So going to the right is east, or 0 degrees from math. North is up 90 degrees. West is to the left 180 degrees. South is down, and it's 270 degrees. So that's one way we could label direction. In general, we say east is positive, north is positive, west is negative, and south is negative. If we say angle A is 55 degrees, the way we label this is 55 degrees from the east, or 55 degrees northeast, north of east. The second direction is where we measure from or where we start from, and we are traveling north. The other way we could label this is this angle. We know this is a right triangle, so 90 degrees minus 55 degrees will give us 35 degrees. When it's 35 degrees, since we are starting from the north going to the east, we write this east-north. So the second direction is where we start from. The first direction is where we are going to. So in this case, there are three ways we could label this. 55 degrees northeast, 35 degrees east-north, or 55 degrees from the east, or the 0 degrees. Let's assume this is 85 degrees. Find all the directions. So in this case, it could be 85 degrees. Since we are starting from the north going to the west, it's going to be west-north. Remember, the second measurement is where we started from. Since this is also a 90-degree triangle, I could write 90 degrees minus 85 degrees, which is 5 degrees. So if this is 5 degrees, this will be measured as northwest because we are starting from the west going to the north. This one we are starting from the north going to the west. And the other way we can measure this is 175 degrees from the east. So right here. Let's say this angle is 10 degrees. This angle is 70 degrees. Find all the possible directions and then check your answers. So for this one, since it's starting from the south going to C, this will be 10 degrees west-south because it started from the south and it's going to the west. The other angle is going to be 90 minus 10, which is 80 degrees. And since it's starting from the west going to the south, this is going to be southwest. And you could also do the third angle, which is from 0 degrees. For the vector D, it's going to be 70 degrees. Since it's starting from the east going to the vector D, this is going to be southeast. Remember, the second direction is where you are starting from. And then since it's a right triangle, 90 minus 70 degrees is 20 degrees. So 20 degrees, since it's starting from the south to the east, this is going to be east-south. You only need to write one direction. You don't have to do all the directions, but these are some possible directions. When calculating vectors, you need to account for directions. You will encounter 3 different types of vector calculations. The simplest of the 3 are parallel vectors. For parallel vectors, all you have to do is account for direction and then add or subtract. If I look at the first set of vectors, we have 6 meters. The arrow is going to the right, so it's going to the east. 3 meters is also going to the east because the arrow is going to the right. Since they are in the same direction, all we do is we add. So 6 meters plus 3 meters, this is 9 meters, direction to the east. The second vectors are also parallel. 9 meters, the arrow is going to the left, so this is going to the west. 2 meters, the arrow is going to the right, so this is going to the east. Remember, in the previous slide, west is negative, so negative 9 meters plus 2 meters. This is equal to negative 7 meters or 7 meters to the west. The next one, next to 7 meters is going northeast. 4 meters is going southwest. These vectors are still parallel. So northeast is going to be positive. Southwest is going to be negative. So if 7 meters minus 4 meters, this is going to be equal to 3 meters northeast. In the last example, the 4 meter is going south. The 5 meter is going north. So this is going to be negative 4 meters plus 5 meters. So this is going to equal to 1 meter north. By the way, you could also make west positive, but if you make west positive, then you have to note that east is negative. Same goes for north and south.